Hi, and welcome to this workshop. Again, thank you for having me. It's a real pleasure to be with you. For today, we will go through the IoT's foundations from standard perspective by giving you the recent trends from that field. We will start by looking at the IoT landscape to set the scene and make sure we are all aware about its extent. Then we will describe the importance of the ISO and IEC as international standard organizations, so industrial can avoid wasting time during development phases and get things aligned to address an international market. We will then have a look from high level at the ISO IEC 30141, which is for IoT reference architecture, and give a recent trend about the latest development within the standard. Without further introduction, let's jump into it. So our landscape, IoT landscape. Obviously, we all have heard about IoT, but let's have a look at the service sector addressed by the IoT, or where the IoT is evolving or will evolve. Let's look at them in clockwise. As you can see, the first one, and maybe the most common one that people may think of, is IT and networks. So it covers public IoT and enterprise IoT. There is a thin barrier between IoT and IT, but we will see that later on how they are interconnected. Let's look at the device side for this sector. So on the device, you can see server, storage, PC, router, switches, PBX, etc. So they are all in why we want to interact with these and make the interaction easy with human and in contactless manner, and make sure that we are interacting all of them together, but as well from a sector perspective. So let's look at the second sector. So security, public safety. So it's related to surveillance, equipment, tracking, public infrastructure, emergency service. So obviously it's related to monitoring the environment, homeland security. So could be related to ambulance, cars, fighter jet, and so on and so forth. So we have other sectors like retail, transportation, industrial, healthcare, and life science. Obviously, we have as well consumer and home, energy, and buildings. Different service sectors, different application groups, different location, and different devices. What we need to remember there is we have different countries as well in the world. And from that perspective, when we say different country, we think about different priority to develop sectors. So let's have a look at these two examples that I gave here. So we have the first one is Grenoble. Grenoble is a city in France. So you can see this article is from the ISO, it's quite recent there. They are willing to be a sustainable city. They are looking at the climate change and the environmental change. So to make sure that everything is sustainable, obviously, but everything is working for the citizen to move on with that. So let's get back into the slides. And so who think about city thinks about buildings, think about energy and transportation. So they are focused on that indirectly to make sure that they fulfill their need. The other example is UK government. So currently the UK government is looking to make some regulation related to consumer of IoT. So they started with a consultancy to see if it is necessary or not, and they found out that there will be a regulation related to that. So, and right now they are at the parliament phase where they are moving things forward. So, and if we move back to our diagram there, we can see that the UK government is focused on that consumer and home sector. Obviously, they are working on other sectors too. But if you want to see what your government is doing, or if you have any questions about how what they are developing and focusing on, so you just need to get in touch with your local government, and they will probably give you some details about the trends in your country. So what we are going to do on the next on the next slide, we are going to focus on the industrial side. So let's have a look at that. So industry 4.0, so it is the industry where it is related to distribution, converting discrete fluid processes, resource automation. So all these words, they are great and nice, but what we mean by that? So industry 4.0 is a connected industry. Is a connected industry in a way that where distribution become instant and virtual. So all parties, contractors, subcontractors, suppliers are interconnected via virtual platform, aware of the parcel location and arrival time. So we may think that exists, but it's not really the case exactly. So we may think about Amazon, they have that kind of distribution, but we are speaking about real time here for industry for processing. So this may look obvious, as I said, but in some cases it's not there. So some supplier, they have their own platform, and other they have different tracking systems. So we need a kind of compatibility there. We need to improve the system. So, and right now it is done manually. We to put that interaction between systems. Some of them are semi-automated, making that not easy from an instant perspective, or to make sure that when you want to get a real-time implementation, it's going to be challenging. Let me give you an example related to the industry. Let's suppose that we are in a factory making pipes, converting raw materials like metal powder or something like that, so into these pipes. So within a factory, we have a big oven to do that, where the raw material get melt to create these pipes in different shape. Obviously, there is parameter to control the oven, like temperature, pressure inside the oven, and maybe the cooling system in case of an incident or at the output of the production chain. So if one of these sensors is faulty, we will not be able to control the melting and baking of this pipe. So you need to predict and avoid disruption to the production. Usually a company don't get damaged instantly. It is due to the frequency of use and how fast you want to get up to speed without damaging the system. This is where the IoT can help by getting all these data gathered instantly and shared with the manufacturer of the oven, and make sure that the oven is still working, and maybe they will provide an instant feedback as they have a view of all these ovens that they have or they are monitoring all around the world. And so they can tell you based on experience if you need soon some maintenance or if you can carry on doing what you are doing based on the consumption that we do or based on the frequency that we have. So they can tell you, yeah, you can plan that in few weeks time. And so from that perspective, it's better than a sudden disruption and shutting down the business eventually. So 4.0 is an industry where resources become automated. So where we are using engine, motors, pump, robots to exploit them. So where laborers will monitor and maintain them, and engineers will build and deploy them. So it's as well the industry where management, operation, and exploitation become easier. They get instant feedbacks, some analytics, and even predict with machine learning and artificial intelligence. So all these computation get done instantly and they get optimized in just one touch of a cell phone maybe or a tablet. So as you can see, there are a lot of challenges. Some are resolved, others are still in progress. But the main issue is how can we make any change within this world where everything will be interconnected. So let's look at that, or let's step back and think about what we need from that perspective. We know that we have the IoT itself is not an issue of Industry 4.0. We have smart cities there, so they will have to adjust the energy distribution based on the daily consumption of district without having a switchboard person behind the system. So the smart car as well. Smart car will be sending messages to ambulance or hospital reporting accident. So you can see that. So it's already existing. So the since April, let's click on that. Let's look at that. So since April 2018, the European Parliament voted in favor of e-call regulation. So it is mandatory, which require all new cars to be equipped with e-call technology in the event of a serious accident. E-call with dial 112, European Single Emergency Number. So let's move back to the slide. So how are we going to distribute these information? To which hospital? In which district? Which security are we going to apply? There are personal information there or confidential information. Can we get the medical record of the driver ready and displayed at the hospital before getting the patient or the driver in? So maybe let's dig a bit into that example. So we said, let's say that the driver had a heart attack, for example. So maybe even getting the hospital, just imagine you have the smartwatch or a pacemaker, even the car sending these reports to inform the first aider team and send the right ambulance or get doctor ready. We can imagine a report sent as well to the insurance company straight away from the moment when the accident happened, with information about the traffic light and maybe the weather condition too. So this is going to change how all these interactions happen. So to solve all these issues, because we are not focused on one interactivity, one connectivity, or one business. So we need a common ground. We need a baseline. We need the same foundation. And so where we can mutualize our resources and bring all these stakeholders and experts to find a consensus. This is where the ISO and IC get involved. This is where we are going to look at in the next section. So, for this section, we saw earlier that we need a common ground, a baseline or foundation to make sure we have interoperability. In fact, when we link that to industry, or the previous model of industry, it was based on a lot of waste of time, waste of energy, waste of resources, waste of people talent. So let me explain. The previous model was based on a rude, cruel competition where each big company will develop its own product and go to market based on their analysis, maybe inspiration, and it will be a kind of betting exercise. It's even gambling exercise because they have no clue if the product will succeed or not. But when they will succeed, they will be obviously happy. But what will happen is the customer, they will have only a unique provider. And so and this is a risky business. Why? Because in case of disruption, in case of the natural disaster, or so there is an interruption into the production. And so this is where customers are looking to have multiple resources or multiple suppliers. And as well, let's think as well about all these companies that we are not able to succeed. So what they are going to do, they will lay down or make redundant employee, and they will obviously will all that impact for their families, as well for business owners and investor. They will lose money. So they will lose their mind as well. So it's a lot of waste of time. So for this is where the approach from the business is becoming different, where industrial standards are here to help defining the requirement. Be careful, I said defining the requirement. Doesn't mean that I haven't said defining the implementation. In fact, each company is still able to implement or to compete from an implementation perspective. They can build their own and different system on their way, but as long it does fulfill the requirement from functionality perspective and additional requirement from safety or regulation, and so from that perspective it becomes safer to develop and to go forward for a market. And this is where we reduce all these waste, and by reducing these parameters we make the competition less rude and less cruel. So let's have a look at how an international standard is developed. So the ISO and IC international organization. So let's look at these two acronyms. So we have the ISO International Organization for Standardization and the IEC International Electrotechnical Commission. They both are closed organization. What does it mean? So this means participating in or contributing to any activity within ISO and IEC is only possible via national channel as a committee member. So people, they need to be a committee member within a national body to represent their national body or national authority, and then they are there to contribute as expert or committee member to take part into that development. So here you can see on the side some logo for different organizations like the BSI, the British Standard Institute, the American, and you have the Australian, French, and whatever. We have in total 164 members. Remember that number, 164 members. As to be aware, currently we have 195 sovereign state according to the United Nations. So when you look at these two numbers, 164 and 195, they are close, which means there is a lot of people or a lot of countries already within the ISO organization willing to contribute and willing to solve some issues there. So the selection, obviously, to be a committee member is not easy, as these people represent the country and are able to contribute at an international level. They are usually recognized for their contribution before becoming a committee member, and so then they are introduced or getting involved in the ISO or IIC. So let's have a look at the national authority, how this works and how this help from a commerce or trade perspective. So we have, for example, the American government, or so in the US. We have the US, they have different departments. Obviously, the Department of Commerce is trying to get much more deals, let's say, for their country, and so they developed at that time the NIST. So the NIST is the National Institute for Standard and Technology. So the NIST is national one. So why? Because at the beginning for the United States, so they have different states. And so to make sure all these states are developing the same way a product, to make sure that they fulfill the same requirement and make sure that there is unicity into their development, they created the NIST. And then when they thought about it, they said, oh, if we are going to start trading outside of the US, we need maybe to push these standard or to find an agreement how, or consensus, how we tweak a little bit the standard that we wrote for internal use to make sure that we don't reproduce or we don't change completely what we are doing. And so this is where they go through the ANSI, the American National Standard Institute, where there is additional other agencies, because it's not only the NIST will participate, but there is consumer group, there is companies. So we take all that and they go into that group at the ANSI, and then the ANSI would represent the United States at the ISO. In the same way, we have the Indian government. So they have different agencies, they have different consumer group, they have different companies running in the country, and each of these has their own needs. And so from that perspective, they all get into the Bureau of Indian Standard. So remember that name, BIS, which is the Bureau of Indian Standard, to get into the ISO and bring all their idea into that standard to make sure that everyone is happy with how things are developed, and exchange as well. So because everyone is participating, everyone is contributing, and we get a consensus, and the same document will be then used after by all these country and member, 164. Remember that one. So let's have a look at the organization itself. Let's take the example of the ISO. So the ISO on the top, you can see there it's written ISO CS, which is Central Secretariat. So the Central Secretariat, they have a strategic role by developing relationship with government and countries. It's a more political role to flourish opportunities and enable the expansion and the impact of the standards worldwide. Then you have the TC, Technical Committee, which is just there. As its name suggests, They deal with technical aspect from a tactical, let's say, side to enable the right programs, avoiding redundancy or producing the standard or when they have been done or related to those are ongoing. So, and if there is any overlapping, they will look at that, make sure that there is the right liaison between groups and subcommittee to make sure everyone is aware about what's going on within all this development. Then, as I said, subcommittee here is or are the entity where the operational side of the standard happen. They are regrouped by items or topic, like the subcommittee 27. So subcommittee 27 is information security, cybersecurity, and privacy protection. So they work into that topic or related to all that topic to contribute and improve what's going on. Then we have working groups, and they are it is where the most of the job is done, where experts are going to brainstorm and get to consensus to produce different standards. As we said, we have 164 members. Some are P member, so participant member, and some are observer member. So observer, that means they are not, they can contribute, but they have no, they are not obliged to be active in their participation. And so all these members, what we need to remember here is all these members, they have one vote. When it comes to voting, one country has one vote. So this is where even the expert need to look at how they deal internally within their country to raise their voice and make a consensus. So let's look at the stage of the development. So when we look at this steps for all these development, we start with a new proposal, we call that. So the new proposal, so any country can come with a proposal. Then we need a resolution for that. So and it become NWIP, which means a new working international proposal. And then we start preparing the standard, working on that, make sure that we develop and get these ideas into a document. We move then into a committee draft, where we need to define how, or if we are happy with that version, then we move into a draft international standard. And finally, we move into the final draft international standard. So all that, so when you reach the final draft, so international standard, you are already at a good level where the standard is almost finished. And this is where we start the next phase, where the final draft is submitted to the ISO Central Secretariat, where by the committee secretary, and then it is circulated to all the ISO member, and they have 2 months to vote and decide whether the standard is suitable for publication. The standard is approved if 2/3 of the P member of the committee are in favor and not more than 1/4 of the total number of votes cast are negative. So the process is a bit long, but we need to respect others' opinion and find a consensus. So the new standard is, so in a way, the new standard is widely adopted. And we can say that even if it is a bit long there to develop a new standard, I can tell you that it is faster than previously. And we are getting even quicker to make sure that everyone is with the technology that we have right now, sharing all this information as well, so we are able to progress quicker. Obviously, from a business perspective, the job becomes easier from the moment your major customer are, for example, out of the country. You make sure you are aware of all these law in their country, all these standards as well used to fulfill the requirement, instead of developing a product then realizing it is not meeting the requirement or regulation from a standard perspective, and you end up restarting from beginning. Your Obviously your team will be disappointed and you will lose money. So this is why it's important to get into standard and to get the standard, understand what they describe, how this will help a business to move on and get things done easily. Now that we had an overview about the IoT landscape and its sectors, and had a view as well about the importance of the international standard, let's have a look at the technical part of the IoT reference architecture.